All right, so what we looked at in the previous video was how to set up our problem. We first of all, we looked at what we're trying to do is we're trying to see the motion of one particle in relation to another, where the two particles are connected via an inextensible cord. And what we said was the way that the initial goal is that we're trying to find our total length of the cord that's connecting them, or the cord rather that is connecting their motions, okay? Which is really the same thing, but what we did was, the first thing we needed to do was get a fixed reference frame, determine our positions, and then calculate our total length. Why did we want to do that? Well, because if we took the derivative of this length equation with respect to time, all the constant lengths would fall away, would become zero. The constant length in this case was CD, and the other constant length was the total length. They would become zero because over time their lengths do not change. But the length of SA will change over time, and the length of SB will change. So the change in this position with respect to time and this position with respect to time is simply the velocities. And so we got VB is minus VA. So as this one moves down 1 unit, that one moves up 1 unit. And what you notice here is the one is the negative of the other. So if block A is moving in the positive direction, plus block B will be moving in the negative. So the velocity of B would always be the negative of A, and A will always be the negative of B. Okay? So again, why did we do the length equation? So that we can take the derivative of this and obtain the velocity relationship. Then we take the velocity equation and we differentiate again with respect to time, and we get the acceleration relationship. So it is really the same. The acceleration of B will always be the negative of the acceleration of A. And in this case, specifically, it's a 1-to-1 relationship. 1 unit of A will give us 1 unit of B, although in the can we say the opposite direction? The opposite direction. Okay? And if we quickly look at this example, what's happening here? Remember, we need to set up our fixed datum. We need to determine our total length. We set up our datum, we set up our positions of each block, and we need to determine our total length, okay? And that total length is given here. What is it? It will be that length there, plus that length, plus that length, plus that length. So 2 times SB plus this is H. It's not focusing so well. There we go. Plus H plus SA. Okay. Then if we take the derivative of this, we are going to get 2VB equals minus VA. Okay. So what is this telling us? So now we can say VA. Let's just rewrite that. VA is minus 2 VB. What does that mean? What does that mean? Well, if VB moves down 1 millimeter, for example, whatever, it's a change, right? A change. That's what a velocity is, right? It's a change in position over time. So if I just talk about the change in position, it goes down 1 millimeter. What's going to happen to block A? Block A, if I put 1 millimeter in here, minus 2, block A will move minus 2 millimeters. So VA will always be twice VB, twice the velocity, twice the change in length, position, twice the acceleration, okay? And it'll be in its negative direction. Okay, so I hope you can just go through this and consider it and think about it. Just notice again, I'm just going to repeat. Remember, we're calculating the total length that's connecting the two particles. But the constant lengths, like you can already notice that that is a constant length, that there is a constant length, that there is a constant length, and this little arc around the pulley is a constant length. Okay, so actually, with respect to this equation here, you could have also seen that this is a constant length. So we have that as a constant length, we have that, we have that, we have that, and we have that. But for some reason, the textbook included this as in the equation, but you can see it just falls away when we take the derivative. So the h, which is constant, falls away, and the total length falls away. These become 0 when you come down here. Okay, so we're left with this for this problem here. Okay, so I hope you're getting the idea, guys. Cheers.